I'm Don Toporowski, and I'm the CEO of ReThink Mining, where we're always on the hunt for new technologies to help us tackle the toughest challenges in mining. And that's what we're doing here today with Voluna. I have the two co-founders of Voluna, Strange and Elias Fernandini. Welcome to Toronto and to the ReThink Mining podcast.
Hi, Don. Thanks for having us. It's great to be here. This is Elias and I's first time in Toronto and excited to share the word about Voluna. So thank you again.
You're welcome. So you and I met Al the first time at Robopalooza, I think it was called, which was it was a conference bringing together robotics people, miners, and people who wanted to mine in outer space. And I thought, okay, well, if we're looking for quick wins here in mining in outer space is not where we want to start. But the most interesting thing I found at the whole conference was your company, Voluna. And we're going to talk a little bit about it. But before we do, I should tell the audience here, Al is a rocket scientist, and Elias is, I don't know what you call it, multi-generational miner. His family has worked in mining for generations. And these two guys somehow got together to develop this amazing technology. Tell us about how you guys met.
Sure. Well, thank you, Don. I'm Al Strange. I'm the CEO of Voluna. And our story is the definition of serendipity. So a bit on my background, I was an aerospace engineer, worked professionally at a rocket company called Blue Origin and then a satellite company called Astronis. Then decided to go to Harvard Business School and sort of rethink my next step. And through that experience and through different classes, in particular an entrepreneurship class I took, I was pitching the idea of mining the moon. Elias was in the classroom. We shortly after there connected. He gave a bit about his background and his family's background in mining, and it just was an obvious fit for us to go and take this technology that I've been sort of brainstorming a business model around and apply it in the near term in the mining industry. So if Elias wants to chime in.
So thank you, Don. I would add that, how we met was basically I took a course at HBS as a cross-registrant. I'm studying at the Kennedy School, but basically it was an entrepreneurship course in which the teacher went ahead and told people in the class, if you have any ideas, why don't you pitch them to the class, see if there's someone that might be able to help you or you never know. And that's when Al comes across and says that he is developing some technology to go mine the moon. And at that moment, I didn't know if I'd heard correctly, but basically I had. And I was super intrigued by it. Obviously, I have a background in finance, always indirectly involved in the mining industry, but that sparked my interest obviously very quickly. So I approached him and told him, hey, what do you mean you're going to mine the moon? It sounds a bit crazy, but who knows? And basically we started chatting and came to the conclusion that why don't we try to first try to mine Earth with this tech? Maybe there's something here as well.
That's a good start. So you got him to settle somehow for Peru over the moon.
Next best thing.
I definitely had to make a case for it, and we started by talking with a lot of geologists in Peru and people in the mining industry to see if there was both a good signal and a good take from what we were trying to do, right? And I think that's when we realized there was a very big and potential opportunity to actually change the industry as we know it.
So in meeting you guys, I learned a little bit about nuclear fusion. Of course, what we all want to see is where two things come together and release energy. This is the holy grail of energy production for mankind. But we can bring those two things together. What are they? They're not atoms, they're
nuclei.
Nuclei. And in the process of bringing them together, we can release other things. And what are those other things if we're not getting energy?
Yeah, I mean, you're getting other things all the time when you're fusing deuterium and deuterium or deuterium and tritium. oftentimes you're producing neutrons. And what many scientists have discovered, and nuclear fusion from energy production standpoint is by all means, or by all accounts, many years away. But in the meantime, scientists have figured out, okay, well, producing power is not quite ready. What can we do with the things we are producing? And one of those things is neutrons. And we can actually leverage neutrons to interrogate materials and understand the chemical makeup of materials by those neutron gamma interactions. So what that means is you produce a neutron, it collides with something, it excites that nuclei, and then that nuclei releases a gamma signature that is unique to the element you interacted with. So scientists understood this as early as 1935 from producing neutrons, and what has now become known as the study of neutron activation analysis to go and actually, again, interrogate materials and understand their chemical makeups non-invasively. And that's sort of the key piece of what Voluna is leveraging.
So Voluna has come up with a little neutron generator, and you're going to send it over the landscape, either with a terrestrial vehicle or now with a drone. And with that, you're going to fire neutrons at the Earth, and you're going to tell us what's in that soil up to 1 meter underground.
Correct. That's right. Yeah, we're realizing there's a real opportunity to leverage miniaturized neutron generator systems as well as advanced autonomous systems like drones that have, in the last 3 to 5 years, have dramatically improved in capability. And when you package these novel sensors with these autonomous systems, what you can actually do is go cover large land packages quite quickly, understand the geochemistry without digging holes or without taking rock chip samples or collecting soils. You can collect that data and then in the same day have the results. So understanding what's on your land quickly without putting people in harm's way, and having it the same day to accelerate your decision making. Where are you going to put your next drill? What other considerations you might have? You have the data to make those decisions faster.
So the way exploration would be not done now, I understand, is you'd go and take some soil samples at certain intervals, I don't know, maybe 100 meters apart, somehow collect those and try to catalog them accurately, then send those soil samples for analysis. And then months later, I'm going to get some data on these widely spaced samples telling me what valuable things might be in the ground.
That's right. Yeah, it starts off very near surface. So when a company has a land package they find interesting, maybe they did some geophysical surveys that sort of pointed them in that direction. But when they want to understand the feasibility of a project, they want to understand the elemental makeup of in the soil and ultimately what is in that ore body, hundreds of meters down below. But what it looks like to start out first is they're sending teams of geologists to the field on foot to collect soil samples. They're bringing picks and shovels, they're collecting dirt, putting them in bags, sending them off site for analysis. And this analysis waiting period, at very best is a couple of weeks. And some conversations we've had recently, people are waiting multiple months for this data. And this data is used to leverage drill placement and other vectoring decisions. If they could have that data sooner or same day, the amount of enthusiasm that we'd seen from geologists, the excitement around same-day geochemistry, it's clear that this would be a big unlock for these mining companies.
So is the advantage that you get more data? I understand you can get data on like a 1 meter resolution. Or is the advantage just that you get your results faster?
I think it's both. And that's why our platform is sort of, we're informed by what the customers want, but we have the capability of getting a data resolution that before would have seemed unimaginable. If there's a really particular area that you're interested in from a geochemical perspective, perhaps it's a gold vein that you're tracking, being able to get meter by meter geochemical data will enable you to follow that vein more closely and have a more accurate picture of what's actually going on. And then simultaneously, you're not waiting for lab delays. We're collecting all the data we need, processing it, and providing those insights back to customers same day. So there's no wait times. And most people are interested in data, and having data same day is something that's never happened in the industry, and being able to get higher resolution as well is another big advantage to our approach. So
At ReThink Mining, we work with some of the biggest mining companies in the world. And I have to say, one thing I have not observed is any of them being in a rush. So why do they suddenly care about speed in this part of their business?
I would say that all the multiple conversations we've had with the different big players, they are slowly, obviously with the rest of the world, realizing that there's going to be some sort of shortage of what the mineral industry is capable of producing, and that makes them obviously want to go into finding innovations or processes that will eventually help them with their exploration capabilities, right? However, we've definitely seen that it's hard to get as an innovation into these big companies because they're so big, and I guess that there's not a process of decision making that gets the innovator and tells the innovator, okay, I'll go through this process with you, and then if you actually come to get a good product that we can use, we'll basically use it, because obviously it helps everyone. They're waiting for us to produce it, and then if it works, they will use it, right?
So has this driven you to smaller miners as a consequence?
Yeah, I would say that we've had so many interviews with different ranges of miners, and I would say, Al, I don't know if you agree, but the ones that are most interested are the ones that are not the biggest top 9 players, but not the junior miners either, because they're cash constrained. But there's a few in the middle that are very conscious about the fact that they need to go into exploration more than ever, and they are willing to both give the support in terms of, hey, this is our operation, how can we leverage this for your innovation, but also through maybe investing or being available.
Do you think speed is somehow more important to these mid-sized miners?
Yeah, I think in general, I would say in the mining industry right now, in terms of exploration timelines, what we saw in a recent convention we were at in Peru called Perumin. It's one of the biggest conventions in Latin America. What echoed across the room with different executives and people in the mining industry all over, from Saudi Arabia to Chile, was that there's a problem with timelines right now. People need to explore and explore faster, and I think that's something we're directly targeting, right? Actually, I don't think the hard problem in this solution is being able to finance it as a miner. I think it's just chicken and egg situation, in that they want to show that wants us to show that there are results, and then they can use those results, right?
So if you were comparing traditional exploration, where they're taking those infrequent soil samples, they're analyzing it, and then making their decision from there, tell us exactly how your technology works and how it's different from that.
Yeah, so as mentioned a little bit in the intro, the fundamental physics that we're leveraging is called neutron activation analysis. But all you really need to know is we produce neutrons, and we leverage the signal that these neutrons create when they interrogate atoms in the ground. So as we're traversing over a mineral concession or even an open pit or a tailings dam, we are directly measuring, based on what those neutrons interact with and the corresponding signals that they produce, we're measuring the geochemistry in the ground. Copper 65, for example, has a particular 7.9 MeV peak on the gamma in the gamma domain. We can train our detection algorithms on that peak. the amplitude of that peak tells us how much copper 65 there is. So this technique goes back many decades and is a one-to-one way of directly detecting elemental makeup. And it's fundamentally different than what's done in the lab. Lab is using ICP analysis. You're collecting maybe 50 grams of soil. You're sending it off site. It's basically through some sort of mass spectrometer, they're able to understand, okay, we have these varying elements at these varying concentrations. But, for the people that we've been speaking with, they have, Elias was sort of talking about, there's a sweet spot of mining companies that have the capital and have the lack of bureaucracy where they can make decisions faster. And they have these large land packages, 100,000 hectares, 200, 300, even 500,000 hectares that when they're doing their traditional approach and they need to bring, many of them have a mandate for bringing more copper mines online. One company we spoke with in Peru was, I think, targeting like 17 or 20. In order to do that, sending people to the field, collecting those data points manually, which can take weeks, if not months, through harsh terrains, and then again waiting for the lab results just to know if there's something there, is way too long. And they see a technology like ours as something that can really accelerate their decisions for, do we have something interesting? Should we accelerate development in this area? Should we divest from land in this other area? So the ability to get data faster, again, is ultimately why people are so interested. And I think for people with a lot of land and the urgency, it's something that's going to be necessary for them.
And is it going to tell me the concentration of, like, how many things are you looking for or at? Like, what sort of report do I get on the different elements in the ground?
Great question. So almost the entire periodic table is up for grabs. There's some elements that are harder to detect than others. What we're focused on first right now is copper. There's clearly a copper boom. I think the latest statistic is, we need to bring 60 or more copper mines online by 2030. So a huge industry focus. People we've been talking to both in North America and South America about bringing copper on specifically. So we're focused on copper first. We've done an initial trial at Scout Discoveries' Speed Goat property outside Winnemucca, Nevada, looking at copper concentrations. And in the lab, we've also begun efforts for nickel characterization, and we'll shortly add in early next year rare earth elements as well. So it's an incremental approach. We're really refining the signal to noise ratio of what we're producing and what we're collecting and how we process that data. But ultimately, what we'll give back to customers is a readout, basically a heat map. Imagine different contours indicating different thresholds of copper concentration or of nickel concentration, so they can, again, go out and make decisions quicker.
So once I have my heat map, can I go back to the places that look most interesting and analyze them in greater resolution somehow? And
right. So
I would say that at the end of the day, we're, as I mentioned before, trying to accelerate the timeline. Doesn't really mean that we need to substitute the current processes. Also, we don't think the mining industry is ready for that, or we are at this stage. But once we have that solution and we are basically giving them an area of interest within hundreds of thousands of possible places where they can go and try to test their campaigns, they can then use their own processes that they're using now in a more targeted way, right? And that alone is just such an unlock for them in terms of timing and in terms of possibly going and going to bigger miners or funds and unlocking new funds for these specific new projects, right? De-risking those projects through our method is, I think, a very clean way of entering in that area.
so have you proven the technology technically? Like, could you go to a chunk of land that's already been surveyed using soil sampling, run over the same grid with your neutron generator and see how your results compare to what they had by the old school method?
Yeah, so it's a process for us. So this is a new, or this technology's been around for a while, but no one has ever thought about miniaturizing it and sending it onto drones. So there's a lot of improvements we need to make to get the actual specificity with regards to we're plus or minus 10 parts per million copper, for example. But what we're doing now and what we've already shown is the ability to get a relative approach might be useful enough for quick decisions. And if we did have access to pre-existing data from a site, we can go very quickly calibrate on a few points and then venture out into areas like that and get that relative concentration right now. So that's sort of where we're at on the roadmap. But we're finding that for many people, that might already be useful enough. It's just a starting point, as Elias said, and either we go back and finer resolution and get meter by meter over a particular area, or they go back in with the traditional approach. But just being the guide with that relative heat map to start out, as we build out the technology, getting closer and closer to more absolute concentrations is the goal. But as I mentioned, relative is good enough right now for people to be interested in what we're doing.
So that's the application and exploration. Down the road, do you think you could use this somehow in an open pit or even underground to help decision making there and improve production? Yeah,
absolutely. I mean, going into a bit of the who we see adding, what kind of customers that we think would be ideal for us. We've already identified, greenfield explorers, sort of, junior miners to more maybe focus on that middle tier size. But when it comes to new types of customers, we've got a lot of positive feedback on an approach to open pit scanning, and more specifically, if you can measure the copper concentration in an open pit in that first meter at a high density and at a high speed, you could inform mine planning about where that ore waste delineation really is, and ultimately where they blast next to harvest and extract that material. So we'd love to do something in that venue. This, working in an operation, there's a much higher bar. So we're focused a lot on greenfield and ultimately identify that as a place we want to head to. And then environmental and tailings. You have mineral waste that's been sitting around for decades that does not have geology. It's man-made. You need geochemical samples to inform and characterize that body. You can't utilize geology. So the ability for an autonomous system to go out into a tailings, which oftentimes are not very pleasant places to be. There can be heavy metals and different acids that are in the area. It's not great to send a human there. If you could send an autonomous system to understand that area from a geochemicals perspective, that would be really powerful. And then also brownfield expansion is becoming very popular, and oftentimes tailings are in the way. So they got to understand and characterize those tailings in order to process them and get rid of them and then expand further. So, we're focused on geochemistry, which is, from a mining perspective, one of the most important data sets. If you understand the elemental makeup of in the ground, that's power. That can improve many things about your operations, and it's ultimately what investors want to know about. Like, what's the grade of copper in this area versus other areas? But yeah, I'll end there.
You have the advantage, though, over some of the other technologies who are trying to get into the operation, to worry about disruption, delays, losing production. You're working in an area where there's a little bit more flexibility, right? They don't have to. You're not going to shut the mine down.
Exactly, and that's the advantage of what we're doing at Voluna. I think that the exploration phase of, I guess, the entire chain of operation is very easy to tap into, just because we're not disrupting anything in the plant or in the open pit mining. If we go to scan for proven reserves, I think that's an advantage that we have, and that's why we've seen the positive reaction from potential clients that are now basically aligning with us to actually go to their operations and provide this technology with them.
So if you're collecting data on 1 meter resolution, is it possible to get too much data, or is just more data is always better?
From our perspective and the conversations we've had, people's eyes light up when you tell them that you can get meter by meter geochemical data. Because if there's something interesting on their property that they really want to identify, doing that in a manual way and then waiting those 3 months is just ridiculous. So short answer is no. I don't think people would ever say no to more data, and especially no to more geochemical data.
Which country do you think right now has the greatest potential for you?
We've seen, I mean, Peru is obviously there, but we've seen that Brazil is very keen on going into mining because they know that there are rare earths there. I think like approximately 10% of the world's rare earths are there. So a lot of people are interested in getting some equity in that space, right? And we've talked to a bunch of partners, potential partners there in Brazil, and they're very open as well to technologies, which is something that is obviously music to our ears.
I think the other important thing too that we've learned is that there seems to be a lot of appetite for companies in South America, in these, Peru, Chile, Brazil, for new technologies like ours. They are, I guess, more hungry, I think, for these new technologies and implementing them into their workflows as a way to get ahead and really champion this macro cycle that everyone is experiencing right now. And it's one of the most mineral-rich places on the earth, and mining has a huge history there. So they're really open to new technologies.
Hey, when I'm talking to people in mining about applications of artificial intelligence, the thing they keep coming up with is that artificial intelligence is being applied in exploration. And that's the place where we're seeing the most realistic applications that are producing the greatest returns. What are they talking about when they're saying artificial intelligence is being used in exploration?
I would say that today artificial intelligence doesn't move the needle as people think it does. I mean, it obviously helps in categorizing and standardizing and cleaning data. But at the end of the day, an AI tool will just give you as much as you input into it. And we're seeing, and we've been hearing from different companies that they give these AI companies their data, their input, and they will basically come to the same conclusions as the regular processes that they've always been using do. The reason being because they have really well-established processes, right? The mining industry has been here forever. So it becomes kind of like a vicious circle of information in which you need to provide data for the algo to actually give you and pinpoint you where to go. But then again, you already have a process that's told you where to go, right? So I think that where it works best is when you have tons and tons of data, maybe from governments, that will help you pinpoint areas of interest. But then again, that those areas of interest are already kind of pinpointed by your geologists, right? So I have yet to see more about how AI is impacting the mining industry, at least in exploration.
But in your case, you're probably generating, or you have the potential to generate more data than any exploration person before you. So what does that mean to exploration?
Yeah, that's a great point. And we've seen AI. We've heard a lot about AI. One meaningful way that we can contribute to AI is through our data and through new types of data sets that Elias and I were in Peru a few months ago, and that was one of the main things they talked about is we need new data sets to inform exploration. And geochemistry, which is what we're collecting, is fundamentally one of the most important types of data sets for exploration. So if we're collecting all of this new data, we can provide it to these AI mineral discovery companies that will ultimately use it as an input to their models to train on. So there's an opportunity for us to help out with AI discovery as well.
I'm going to ask you the same thing I ask everyone who comes into the ReThink Mining podcast studio. If you were to ask one thing of the miners who are members of ReThink Mining, what would you want from them to help your technology grow and succeed and change mining?
I think a meaningfully sized pilot. And the ask from us from a pilot perspective is not so much of paying us to do work, but is facilitating the access, the data, potentially the lodging and any other know-how that we would need going into new work on a property. So I think that's the biggest unlock for us, because the conversations we've had with many people is, if you demonstrate this in a couple different places, like the technology would be very commercially interesting to us. So it's all about getting pilot demonstrations right now for Voluna.
So you really need the attention of the miners more than you need their money.
Correct.
Let's give Voluna a little attention, help them get those pilots going so that we can accelerate exploration and change mining together forever. Thanks for coming here today, you guys, and good luck to Voluna.
Thank you, Don.
Thank you, Don.
Appreciate it.
Yeah.